Okay, so let's start with today's second talk, which is going to be about a collaboration between Flink and other Apache projects, namely Apache BigPetStore. And it's going to be implementing the so-called BigPetStore application. It's called BigPetStore because the setting that we have is supposedly a pet store or pet stores. You are a customer, you have a location, and you want to go around and shop for your pet. That's basically the setting that we are looking for, which is going to be a data generator. And we are going to do all sorts of cool stuff on that data that this model has generated for us. And practically the way you should look at it, that it's sort of a template of how to use Flink in very little code to achieve great things. Okay, yeah, now it works. So, a little outline. I would like to give you an intro to the BigPetStore model. Then we are going to do data generator in the DataSet API, so we go batch. Then we do some ETL with the DataSet API and with the table API. Then we do some matrix factorization for a Recommender system in FlinkML. And to add some sugar, we'll do the DataStream API and use it for recommendation prediction. And we do the whole thing under 500 lines of code, so I copied a lot of the code to the slides and we will go over it together because it's not that much, that's the whole point. We will use both the Scala and the Java API to accomplish all this. So let's get started with the BigPetStore model. And I would like to ask a rhetorical question. Imagine that you are in that situation with Samuel L. Jackson and he tells you the following. Okay, introduce big data processing for me, but you cannot say the word count. How do you do that? And currently my job is to convince you that one way to do that is to introduce it through BigPetStore, because it's going to give you a bit deeper view of big data processing. Because of course every processing needs a hello world type application, and word count is cool for that. But if you want to actually explore all the things that these systems can do, you need to dig a little bit deeper. And BigPetStore basically gives you that kind of, let's dig a little bit deeper to the application and all the capabilities that it gives you. So basically the whole project implements of some data generators, examples of using these big data tools, and it also comes with build systems when it comes to BigTop. Currently this, and BigTop is a bigger project also on deployment and provisioning, but these are the generator parts, and one of them is actually called BigPetStore. There's already a BigPetStore implementation in the main bench of Apache BigTop for MapReduce, and another one for Spark. And as soon as I finish my talk, I'm going to prepare the pull request for Flink, and we have a couple of BigTop committers pushing it, so hopefully we will get that in. So a little bit more in the model. I already gave you an intro that basically you should imagine that you are a customer, you have a location, there are shops around you, and basically it's a Markov model of how you would shop around for your pet. The way this is why it's important, there's actually a research paper out on it, is that regardless the scale on which you need the data, maybe it's 1 gigabyte, maybe it's 10 petabytes, it is designed to give you somewhat useful data based on the needs defined in the paper. So that's why it's important, and that's why you can use it also for benchmarking and not just as a template. And let's get to the coding part. So one of the BigPetStore guys, Ronald, has implemented the model in some Java generator classes, and we are going to go over that real quick. So of course, for every DataSet API program you need an environment, and then for the model we get the data from Ronald's Java generator classes. Basically we need three things: the stores, the products, and the customer. Ronald did that for us. This is the ground truth on which we are going to generate our data, and we are going to generate our data in Flink. So basically the way I decided to generate the data and to feed all these 3 data sets into the DataSet API is to have the customers as the input data, because that was the biggest data set that was generated. And then I passed products, which was a real small, or product categories, which was a real small data set, as a constructor parameter. And there's a third option that I could use, which was a broadcast data set for a medium-sized data as stores. There's also a little thing about the model that I added here just to tell you how easy is it to access the data and modify these things. When you actually fire up Ronald's generators, it's going to assume that we are on day 0 of the data generator. And if you want to have something that is more useful, maybe you would like to say that, okay, let's start generating data on the 26th of January, then you just add the start time to all the transactions, and then at the end, when we write this output, you will have something meaningful. And we are going to depend on that in our demo today. Okay, so far so good. We managed to generate some data, and we could write it to JSON. So right now the toString of the Flink transactions that we are generating here is actually writing them to JSON. The next step that you can easily do with the DataSet API and the DataSet utils is to clean this data. The input that we are going to need for our recommendation is whether a customer was interested in a product. So instead of these transactions, which have a lot of data and are not particularly useful for the recommender systems, we just need to extract 2 things: a customer ID and the product ID, that these 2 are linked. The recommender system doesn't really care, or the basic recommender systems don't really care about anything else. Okay, how do we do that? And I add another challenge into the mix. Customers, because we have generated them beforehand as a ground truth, they have a unique ID. So we can use that in the recommender system. However, products don't, because we only have product categories. So like, this is a doggy food, but we don't have the whole product, which we are going to use the price of the product, the weight of the product in this. So actually, we need to pre-process that, and we need to come up with a unique ID for the products. One way to do that is by relying on Flink's dataset utils in the Scala API. Is I get all the products from the transactions, then I do a distinct, and then from dataset utils, I call zip with unique ID, and bam, I have for every product, I will have a unique ID. Now, of course, for every transaction, on the other hand, I can get all the products that were involved in that transaction and the user ID. That's what I'm doing right here in this flat map. And if you stop for a second, what's happening right now? I have a product and its ID, and I have the customer ID and the product. All that remains is to join those 2 and do some magic on Scala tuples, do a distinct at the end, and we actually arrived at the output that we wanted to have. So this is some basic ETL and transformations with the DataSet API and the DataSet utils. What if you wanted to do some SQL-style queries? Of course, Robert already told you the plans, but let's have a look at what's already in there and what you can already use today. And I've sketched an example of selecting the stores that have had the maximum transactions in all our data. Of course, to do that, you again need a join. maybe we have our stores as a store ID, a store name, and a count of how much transactions they had. And from our transactions data set, actually to convert to table, all we need to do is a little bit of playing with the rough edges of the table API, which are to be lifted. And then we group by store ID. We select all the fields that we need. This should be very familiar from SQL. And count all the store IDs in every group. So now we have count. At the same time, we can select the maximum of the store IDs in the same groups, join those two together. Wherever we see that the count is the maximum, we just select out the right fields, and we have arrived at actually knowing the most performant stores in our model. Okay, so now we've seen basic ETL and some table API SQL style. How about doing some recommendations for our customers on this data set? For that, we'll need a little background knowledge of Recommender theory. Who of you have used a collaborative filtering Recommender before? Okay, almost half of the interested population here. That's great. So I'm not talking to you now. I'm talking to the other guys. So basically, in general, when we are doing this recommendation collaborative filtering, the basic outline that we have is, okay, we have some users and we have some items. And to collect the ratings of the users on the items, we can have this R or rating matrix. And basically, the rating matrix says that this user rated this item to rating 5. There are a couple of problems with that matrix. For example, you only know a couple values of them. Usually 90+% is not filled, because if you have 10 million items and a couple million users, of course all the users are not going to watch all the items. Maybe you are a video streaming service and you would like to recommend new videos to your users. Or in the BigPetStore application, you don't expect every user to buy every product. That would be a very perfect world if you were to sell pet stuff. So, okay, this matrix is very sparse. The next problem, it's very big if you think about it, even if it's sparse, because as I told you, it's easy that both of the dimensions are in the millions, or they can go even higher. So how are you supposed to store that? And one way to do it from basic linear algebra is to use the following trick. Of course, this matrix is very big, but if we had a matrix that has the following properties, one of the dimensions is the number of users, but the other is some small k, maybe 100. And the other matrix has the right dimension k again, and the other dimension is the number of items, then actually the the matrix product of those two can have the same size when it comes to the matrix. And then of course we can make sure that with this size you can approximate the original R if you use the right algorithm. That's basically the idea behind matrix factorization for recommender systems. So then you get two smaller matrices that you can actually store and still get a nice view of how the rating matrix should look like. Okay, so far so good. Given that you have P and Q, which are the user factor matrix and the item factor matrix that have these properties that I just described, how do you actually give a recommendation? That's a very important point, because that's what we add at the end in streaming. Think about it. When it comes to this row, the row of the rating matrix for this user, this actually contains all the ratings that this user would have given, supposedly, for all the items if he or she watched them or bought them. So given that you can compute all this row and choose the top k of that row, you are good. So maybe you want to give 3 recommendations, you complete the whole row of the user in the rating matrix, which is just multiplying this row of your user factors matrix and the whole item factor matrix. And on that, you compute top K and you are done. And that's quite easy to do in the distributed settings. So we have to do 2 things now. One is to use FlinkML to compute P and Q for us. And then we are going to give, and then we have the model. And then we can stream in user IDs that, okay, Robert just popped up on our fantastic website and we want to give him recommendations. And that's what we are going to do in a streaming setup. Okay, how do we use FlinkML? And one of the guys who wrote FlinkML, Theo, is sitting back there, so hopefully he is enjoying the nice API that they have come up with till, because okay. The thing is, to actually produce this model is this much. Remember, we have written out the user product ID pairs to a CSV file previously. So we just read that in, we do some little bit of loading on them, so we actually get vectors, and then we just say that, okay, I want an alternative least squares model, which is a standard solution to these factors. I set a couple of parameters because I feel that they are necessary. Then I say model.fit input, that's it. Now I get my model. Usually you would say model.predict on a data set, but now I want to go very fancy, and instead of using the FlinkML solution, I want to use Flink streaming to actually compute the prediction. So that's it. If you use the FlinkML library, that's actually how much code you have to write. And we actually arrive at the DataStream API, which I decided to use in Java instead of the Scala version. Well, the semicolons are missing. That's on me, but it's coded in Java, and I will show you in the demo. Basically, then all we have to do, given that we know P and Q, is this multiplying this vector by this matrix, as I already suggested. And this is cool because it's quite easily parallelizable. We can partition Q and do the computation in a distributed fashion. So basically the outline of such a Flink streaming program would be the following. We can read the user IDs maybe from a socket. That's what we are going to do in a second. Then we get the corresponding user vector from P. Then we send that in a broadcast to all the partitions of Q. Then on that we can compute a partial top K, and then we send those into a global top K, and then just print the result. Let's see this in action. So we'll pop up IntelliJ, enter presentation mode, and let's see what we have here. This is the data generator. As I have already told you, basically we have a first part when we are using Donald's code, and then we just generate our data. Let's actually run this. So we have some output from Ronald to that he have read our data, and then Flink runs, and that's basically it. We have the output there. Then the next thing that we need is the ETL part. As I have already told you, this is going to do 2 things. First, get the nice pairs of products and users. That's what we are doing here. And then we are going to do this SQL style computation for the counting the most the stores with the most transactions and all the counts per month as well. for that to return at the end, we use collect. That's something that I haven't put on the slides. And let's look at here. Okay, so as I suggested, we also have monthly counts at the end. If we scroll a little bit up, you will see that the length of the simulation is 100 days, and we started today. So actually, the simulation was running up until the 5th month of the year, and that's, I think, something that's expected. Okay, so let's train our factor model based on this. As I told you, this is the code that I've shown in the slide was really the actual code there. And now we can jump into streaming. For that, we'll need a socket, so I will bring that up real quick. And go back here and run this. And then we get to choose a user ID for which we would like a recommendation. Of course, we are using we'll use Robert as an example. He has to be the first ever user. And Robert, I suggest product 51 for you. That's a very good question. I will answer that later, just for Robert's sake. Okay, so a little summary. If you want to go beyond word count, BigPetStore is an option. In 20 minutes, you have seen a lot of the APIs that Flink gives you. There are a couple others, Jelly, the Storm compatibility layer, and more to come, as we have seen today. But this is how much I could pack into 20 minutes. You have seen a lot of functionalities under 500 lines of code. The Java and the Scala API working well together. And of course, a pet project with Flink, that should be fine, huh? And big thanks to the guys who supported me carrying out my pet project. Thank you very much. Woohoo! Yes?
Can you quickly summarize BigTop, what they are doing?
That's a good question. The last time I managed to meet the BigTop guys during the last ApacheCon in Budapest, and the way I felt that they originally started out as a tool to help deploy all these big data applications, and then they found out that it would be also nice to somehow fail-proof these deployments. And that's how these data generators and benchmarks come in. So it should be a complete solution of deploying your application on any given backend, and then using these benchmarks to fail-proof them and make sure that you have a nice installation with also some benchmark capacities. So that would be the whole project as I understand it. It's somewhat interesting in the sense that it's quite an old Apache project. Some parts were founded quite long ago, but these parts are fairly new. So it's difficult to describe how much BigTop actually covers.
But I thought it's also the only real open source Hadoop distribution.
Yeah, and that's also true. That's also, yeah, from that perspective, and from what I know, a couple of big Hadoop distributors actually base their distributions on BigTop, and I think it's better if I don't name them, then I don't make a mistake. But there are a couple of big ones actually based on BigTop. So for that, it's quite an important project, and I think it should be great for Flink as well if this code gets in. Okay, thank you very much.